In this video, we are going to add and subtract polynomials. So we're going to start with addition. What you see on the screen is you see two polynomials, each encased in parentheses. So you can see here that we have a trinomial plus a trinomial being added together. And hopefully what your gut is already telling you is that when you have parentheses without a number in front of them, you should know that there is really a 1 out here in front of parentheses. And what we can do is, in order to get rid of those parentheses, we can take that 1 and we can distribute it to every item on the inside. Now, I strongly recommend using keep, change, change here so you don't make a mistake with your signs. But if we distribute out that 1, we find that we have 2x cubed plus a negative 5x squared plus, this is really a 1 here, so 1x, plus, in the second parenthesis, we have 2x squared plus 1x cubed plus a negative 1. So what I've done here is I've distributed out those 1's in order to get rid of the parentheses. Then from here, if I think back to what I know about algebra and terms that can be combined together, I know that we can only add together like terms, which means we can only add terms together with identical variable parts. We have to have like terms. So as I go through, I'm going to pick the highest degree because I like to start with the highest and then rewrite it down to the lowest degree. But what I notice here is that cubed is our highest degree. And I notice if I look through all of my terms that there are two terms that contain the x cubed. And because those are identical variable parts, they can be combined together by simply adding their coefficients to be 3x cubed. 2 plus 1 is 3. Then from here I move on, and I notice that there are a number of x squareds. And here when I look carefully, I notice I have a negative 5x squared plus a 2x squared, and negative 5 plus 2 gives me a negative 3x squared. Then from here I move on to look at terms that contain just an x, and I notice that there's only one, so that stays plus 1x. And then I notice that the constants without a variable, I'm left with just a constant of negative 1. Now from here I've written these using keep, change, change. Your other option is you can write those plus negatives as simply subtraction signs. Either one of these options will be correct. So let's try a second example here. Here again I notice that I have two polynomials. This is a 4-term polynomial and this is also a 4-term polynomial. And what I'm going to do is I'm going to combine them together as much as I can. Now in order to get rid of the parentheses, I know I need to add a 1 out in front because there's really a 1 in front of those parentheses. And then I'm going to use keep, change, change to fix those negatives before I start. So in order to get rid of those parentheses, I know that I need to distribute the 1's in front of each parenthesis. So if I take 1 times the first set of parentheses, I get 3x cubed plus 4x squared plus 6x plus, that should be plus a negative 4. Then if I distribute the second set of parentheses, I get 4x to the 4th plus negative 5x cubed plus negative 2x squared plus 10. So now that I've distributed and gotten rid of the parentheses, the next thing I'm going to look for, remember, I'm going to look for like terms to combine together. And I typically suggest that you start with the highest degree terms and then work down to the smallest. So as I look through, I see x cubes, x squareds, x to the 4ths, x's, and numbers. And I notice that x to the 4th is my highest degree term. And it's the only degree term with a 4th degree. And as a result, I'm going to just write 4x to the 4th as it doesn't combine with anything else in that statement further. Then if I look further, I notice that x cubed is my next highest degree term. And I notice that there are two items that contain an x cubed. So if I combine those together, 3 plus negative 5 is a negative 2x cubed. Then from here, I look and I notice I have multiple x squareds. And as a result, 4 plus negative 2 leaves me with negative 2 x squareds. Then from here I look and I notice that I have terms that just contain x, and I only have one of them. So that's just going to stay 6x. And then I have two constants that don't contain a variable, and those can be combined together to be 6. Now if you don't like the plus negative part, the other way this could be written is 4x to the 4th minus 2x cubed minus 2x squared plus 6x plus 6. So now we're going to move on to subtraction. And remember that as we get to that combining part, we can only add things together that contain like variable parts. So we're going to go through the same process here. I notice that I have a 1 out in front here, as well as a 1 out in front here. And then I'm also going to go through and utilize keep, change, change wherever I can. So here I look, and my first distribution is just distributing a 1, so I have 4x cubed plus a negative 7x squared plus 1x. And then I notice that as a result of using keep, change, change, this second set of parentheses, I'm really distributing a negative 1. So negative 1 times 3x squared is a negative 3x squared. Negative 1 times negative 2x cubed is a negative times a negative, so a positive 2x cubed. And then a negative 1 times negative 8 is a positive 8. So notice how this second set of parentheses has a negative 1 get distributed to it, and as a result the signs of all three terms actually change to be the opposite of what they were. Now from here we're going to combine our like variable parts, starting with the highest degree. I notice the highest degree is x cubed, and I notice I have two terms that contain an x cubed for a total of 4 plus 2, or 6 x cubes. I then notice that I have two terms that contain an x squared. Negative 7 plus negative 3 becomes a negative 10 x squared. I then have one term that contains an x, so that stays just 1x. And then I have one term that is a constant, that just stays a constant. Now again from here, if you don't like the plus and negative, you could write that as subtract 10x plus 1x plus 8. Either one of these answers will be sufficient. And final example here, so again we're going to put in our ones where we need to. Then from here I'm going to utilize keep, change, change to prevent myself from making an error. And then I'm going to start by distributing out the ones so that I don't have any more parentheses. So this first set, each term gets multiplied by a positive 1, so we have negative 2x cubed plus a negative 9x squared plus 4x plus a negative 16. And then as a result of keep, change, change, notice here that I am distributing out a negative 1. So it's going to be negative 1 times a negative 4x to the 4th. Negative times a negative is a positive 4x to the 4th. Then a negative 1 times a positive 1x cubed, so this is a negative 1x cubed. Negative 1 times a negative 9x squared. Negative times a negative is a positive 9x squared. And then negative 1 times negative 8 is a positive 8. So then from here I'm going to combine like terms together, starting with the highest degree term, which I see is to the 4th power. So here we have 4x to the 4th. Then I move on to x cubed, so that's my second highest degree. Negative 2 plus negative 1 is a negative 3x cubed. I then move on to the x squareds, and I notice that I have negative 9x squared plus 9x squared, which totals 0x squared. Then from here I notice that I only have one term that contains just an x, so that's plus 4x. And then I notice that I have two terms that are just constants with no variable that can be added together to be a negative 8. So now there are a couple different ways you can write your answer. The first piece is that this 0x squared really just equals 0 because 0 times anything is 0. So you don't actually need to include this in your answer. You can, it's not wrong, but you don't need to. And then you also could write your plus and negatives as just subtraction signs here, if you would like.